Uh, Hello and welcome to this session. In this session, I'll solve one problem of epicyclic gear train. In addition to solving the problem, we will also see the method how we can solve any of the problem of epicyclic gear train. Basically, we are going to follow one tabulated method, and that is very easy to understand as well as to apply uh, on the epicyclic gear train. So this is my problem. I am having one epicyclic gear train. This picture basically showing the side view of epicyclic gear train, and this is showing the front view, you can say. If I'll see from this side, I will see this kind of structure, which is both are not exactly same, but I request all of you that you should have a visualization, that if this figure is given to you, you must have a visualization so that you can make this figure. On the other end, if you are having this picture, you can also make this picture, but it is little difficult. So normally this kind of picture is available in the question, and using this picture either the second will be given to you or may not be. So you have to visualize that what would be the second picture, because it is required to calculate some of the quantity. Now before I discuss the diagram, I will state the problem. The problem says that this is an epicyclic gear train where there are gear S, planetary gear P, C, gear D, gear A and D are ring gear having internal teeth. This is your arm mounted on the shaft 1, and gear P and C are compound gear, means both the gears are mounted on a single shaft, so that the rotation speed of P will equal to rotation speed of C. And in the question it is given that the input S has 24 teeth. That means there will be, this is the input shaft. I am saying that this is input shaft and having number of teeth 24 on gear S. P and C makes compound, and TP and TC means number of teeth on P gear and number of teeth on C gear are given. Now we have to find the reduction in speed. So basically shaft 2 is the output shaft, shaft 1 is the input shaft. As we already defined that an epicyclic gear train has 2 degree of freedom. Please remember, the epicyclic gear train has 2 degree of freedom, and to get a single output we have to supply 2 input. Here also it is given that we have to find the reduction in the speed, means if I am giving an omega to first shaft, what will be the omega of the second shaft, because the power is going to transmit it through this complex gearing system. And it is given that A is fixed. A means this annular gear or ring gear is a fixed gear. So here what we are giving one constraint to A, that means this is my one input. The second input will be to shaft 1 and the output will be to shaft 2. That means I am giving 2 constraint or 2 input to my system and getting 1 output. It indicates that the system has 2 degree of freedom. So now I will first show you a 3-dimensional picture of this figure so that you will have a better picture of the system. So here I tried a 3-dimensional picture of this system, and now you can see here that now you are having all the 3 pictures. So this is shaft 1, which is here. This is arm. Arm is actually mounted on this shaft 1, but it is not rigidly fixed to shaft 1. That means the arm can rotate about this shaft. So this is my arm. Arm is connected with one shaft which is having gear P and C. So this is the shaft. This larger ring gear is representing gear A. So this is my gear A. This is my gear P. So this is my gear P, which is planetary gear. This is my gear S. S is connected to this shaft, and S is connected to this shaft rigidly. That means if I am giving a rotation to this shaft, S will have rotation. The power will be transmitted from S to P and from P to this annular gear A. Now this gear can also rotate about this S gear. Now this shaft is going forward, and there is another gear which is your gear C, which is showing here. So this is my gear C, which is having mesh with gear D, and here also the gear D is having internal teeth and gear C is having external teeth. So this larger one is my gear D, which is connected with the output shaft. So now you can just understand that this is the complex system, and in this system I can get different output by making different constants. For example, in the given question it is said that gear A is a fixed gear. So in this case, now if I will give certain rotation to this shaft S, what will happen? The S will rotate. Because of the S, this gear will rotate, but this is a fixed part, so at the same time this P gear will also revolve around the S, and as it is revolve, this C will revolve, at the same time it will transfer power to D, and finally I will get an output. In this question, it is also important to understand that suppose I am having number of teeth on S gear, and I know the number of teeth of P gear, but I don't know the number of teeth on gear A. Why I am telling you this? Because if I know the number of teeth on S gear and P gear, I will be able to get the number of teeth on A gear, because all the gears are having same pitch, and as these gears are having same pitch, I can follow that the number of teeth on gear A will be equal to twice of number of teeth on gear S by 2 plus number of teeth on gear P. Now you understand how I am doing so. The one way, just directly, this is the half of the diameter of the S, so you should write TS by 2. This is complete diameter of P, so you can directly write TP, and this distance is half of the diameter of the A, and ultimately the diameter and number of teeth are equivalent if we are having same pitch. So if you are interested to find the number of teeth on gear A, you can use this formula. At the same time, if you are interested to find number of gear on D, so how you will reach here? So how you can reach here? If I will start from here, I will say, and suppose I know the number of teeth on gear C also. So what I will do, I will consider this distance, then this distance, and half of this distance. So that I can write that twice of TS by 2 plus TP by 2 plus TC by 2. So this is very important. In all the most of the cases, all the number of teeth on all the gears are not given, but we know that pitch is equal for all the gears. That means I can consider the radial distance of the gear, and that radial distance can directly convert it into number of teeth. So in this case, if I want to find the number of teeth on gear A, I can use this formula. If I am interested to find the number of teeth on D, I can use this formula. Similarly, if any of the gear doesn't have number of teeth and other gears, we know the number of gears on other teeth, we can find the number of teeth. So now let's go back to the problem. That this is my problem where I am having the given condition says that A is a fixed gear, but before we solve the problem, first thing we have to make a table, and this is standard. I have already discussed this in my previous lecture, so here I will just show you that how you can make the table. The standard style of making table says that first you will make all the gears. So this is my arm. After the arm there is a gear S. After S I am having a P gear, and P and C are same, so I will just put P oblique C. After that I am having my A gear, so I'll put A. After that I am having another gear D, so I'll put D. So now I have considered all the rotating members of my system. Now first step is fixed arm. This is standard procedure. Every time you have to fixed arm. As I will fix my arm, I will put that 0 RPM or 0 rotation here. Now let's give an input X to my S gear, and consider that I am giving a rotation in the counterclockwise direction. If I am giving my input in counterclockwise direction and the magnitude is X, that means the rotation of P will be what? These two gears are in mesh and arm is fixed. That means these two are like a simple gear train. So the rotation or the RPM of P gear will be opposite to the direction of S, as well as it will define by TS by TP. Now what will be the rotation of A? Please remember that when we are making this table, we are not taking input from the question. Finally, when we will have our table, then we will take this input. So here you will not consider that A is fixed. Here you will consider that all the gears are free, and now I am fixing, initially I am fixing arm, A arm, and I am giving one input to S. So now I am having two inputs, and I am calculating the output of all the gears. So now my A will be what? A is here and A is in mesh with P, so I can write that the rotation of A will be whatever rotation I am having for P multiplied by TP by TA. And remember here, the direction of rotation of P and direction of rotation of A will be same because it is having internal teeth. So if I will solve this, I will get that this ultimately coming out when I will put this value, because this is the rotation of P which is here. So when I will put this value here, the PP will be cancelled out and I will get minus X, and that TS by TA. So this is the rotation of gear A if I am giving an input X to my gear S. Similarly, D is also in mesh with the C and the direction of D and C will be same. So I will write here that the RPM of C or RPM or rotation, whatever you want to say, into TC by TD. When I will put this value here, I will get that this rotation will be minus X TS by TP into TC by TD. So you can see here, and this table you need number of teeth on gear S, P, C, D, but in the question only P, C and S are available. So that means we have to calculate number of teeth on gear A as well as number of teeth on gear D, which I have already explained you. Now this is the first row, and please remember, if you will be able to write the first row, the problem is 70% solved. Now the next step is very simple, standard, that says that if you will give rotation Y to all the members, there will not be any change. This line is little difficult to digest, but this is a standard way and I can explain you that why we do so. We are doing it in a way that let's consider that all the gears are free to rotate, and if all the gears are free to rotate, if I will give a rotation Y to my arm as well as I will give rotation Y to my S, that means I am giving two input. If I will give two input which are equal, you know that arm and gear S are independent to rotate, so I can apply different forces on arm and S, and here what I am doing, I am intentionally giving a rotation Y to my arm and rotation Y to my gear S. If I will give Y here, you will find that all the other gear will also have rotation Y. This part I have already explained in my previous class. Here also quickly I can explain you that how it is happening. Let's understand that this is a system of gear where this is gear S and this is gear P and this is my arm. Now if I will free gear S as well as I will free this arm. So now if I will rotate my gear S in this clockwise sense with a rotation Y, as well as I am giving a rotation to my arm and that is also Y. So if I will rotate these two members, the P will also rotate and the rotation of P will be Y here. Now how it is happening? It is happening because you just understand that this is my system. Now this is the radius of, this is gear A and this is gear B, this is S and P, sorry. So this is RS and this is RP. Now let's consider the arm and assume that this is fixed. So now I am assuming that this is fixed and I am giving rotation to arm. If I will give certain rotation to arm, I am giving a rotation omega arm here. So the velocity of this point will be equal to omega arm into sum of these two radius, that will be RP plus RS. Because it is simple, this is a fixed point, the arm is rotating about this point, and if I am rotating my arm with angular velocity omega arm, the point that is here will have a linear velocity, that will be omega arm multiplied by distance, that is the sum of the radius of the gear S and gear P. At the same time, when I will give rotation to this arm and I am fixing this gear, this P gear will also rotate. And if I am assuming that the rotation of this gear is defined by omega P, and just try to recall that if something is rolling on a surface and its rotation is omega. The center also move with a speed omega r, that this is the radius r, because when something roll on a surface at the time, this would become the instantaneous center, and if I will try to find the velocity of all the points on this line, the center will have a velocity omega r and the top point will have a velocity 2 omega r. So using this philosophy, if something is rolling on a surface, the center move with a velocity omega r. Here also the P is rolling on the fixed gear, so the center will also move with a velocity omega p into rp. And these two quantity will be same. So if I will calculate rp, I will find omega p here. Omega p will be what? Omega of arm multiplied by this 1 plus rs by rp, which can also be replaced by 1 plus ts by tp. Omega arm, that is my omega p. So now this is one condition which says that if I am fixing this gear and I am giving certain input to this, the output will be this one. Now let's take another condition. Let's fix the arm. If I will fix the arm and I am giving similar w omega arm input to my fixed gear. So if I am fixing this and I am giving rotation to this, if I am giving the same rotation in the clockwise sense, so my rotation here for this larger gear, for gear S, is omega arm. Now omega arm into by omega p will be what? T. You can say that if I am interested to find the RPM of this larger gear, what will be the RPM of smaller gear? This omega p in that case will be minus omega arm multiplied by this ts by tp. So this is the output if I am fixing arm and giving rotation to the larger one, and this is the output when I am fixing this larger gear and giving rotation to this arm. Suppose I am making free these two gears and giving same input to both the gears. In that case, these two terms will add on, and if you will add these two terms, what you will get? Finally, the omega p means that when I am adding this and this term will cancel out, and ultimately the rotation will also omega arm. What does it mean? It means that if I am giving a rotation y or omega arm to this gear, as well as I am giving a rotation omega arm or y to this arm in the same direction, the third gear will also have the same rotation. Similarly, if you are having number of gears and you are giving input to two members, other members will also have the same rotation if all the members are free to rotate. So this is one standard method, and you no need to remember what I have just explained you. I told you because I thought that you should know that why this yy is there. Now once you have this yy, now you can simply add these two terms. So this is y, this will be x plus y, this will be y minus x ts by tp, this will be y minus x ts by ta, and this will be y minus x and this term, that ts tc by tp td. So now I have completed my table, and after that I am going to take input from the question. So for making this table, no need to even read this question. Once you have the system, you can make the table. Now after making the table, here it is showing that a is fixed. So what is the velocity of a? Then that means this would be 0. So this is my one equation. Second, they are saying that I am giving input and I am interested to find the ratio of s to d. That means I am interested to find the ratio of this value to this value. So if I will say ns by np nd, that will coming out that x plus y divided by this term y minus x ts tc by tp td. And as I already explained you with this figure, that if you are interested to find the ratio of gear A, number of teeth of A and D, you can use this formula, and from this formula, if I will put the value of SP and the C value, I am getting that this TA is coming out 84 and this TD is coming out 72. Now when I will put this value here, I will get a relation between X and Y, because TS and TA is known to us. So when I will put this y is equal to minus x plus x ts by ta, and when I will put this y value in this formulation and I will take out x common, so my problem will be solved because s will be cancelled out, and finally I will get that these, so you can say that these are the two equations. So I will put y is in this, so it will be x plus x ts by ta divided by this y x ts by ta minus x ts tp tc and td. So this x will cancel out, and when you will put all the value, you are getting in value 15. That means the reduction in speed will be 15. Means the ratio, if you are rotating something with the 1500 rpm, the rotation of this shaft will be only 100 rpm. This, so I hope that I tried to I explained you the problem. Even though if you have any problem, you can message me, so I will try to answer your queries. So quickly just have a review that this is your problem. The first thing what you need to do, you have the visualization so that you can make this table. Once you will make the table, the problem will be solved. After making the table, I am going to take input from the question, and then I can get the required quantity. Out of this, what I told you, that why we need this y here, that is just my explanation. If you are not understand this, no problem. In my next video I will try to again explain this, but at this time you should focus that how to solve this numerical, and the numerical I have solved. Okay, so thank you for this session.